Today, well, it's one of my hats. Growchano is a business angel club, network, team. And yeah, we want to promote startup ideas from this region, but not only. We invest in other startup ideas. We have done so over the last 3 or 4 years. And yeah, today is about AI, as I said, and we have two, let's say, colleagues of ecosystem, Bogdan Berchan from Rayscape and Mihai Tătăran from Avelgo, and they will present two, let's say, their view on AI, how they deal with AI these days. But before that, I just want to tell you a quick personal story. It was around 2012, 2013, when some guys from Google, you work with Google now, came to us. I was working for a small company, Irish company called Movidius, and they came to us and said, we want to look at your hardware, your chip, and we want to run a few experiments on your chip. And basically, they took it to Silicon Valley. They obviously they had to integrate a few things, work on our framework, and they came back and they told us it's amazing. I think we reached the sweet spot of technology. That was in 2013 or so. We are able to run neural network on your chip. And we were, you're what? We run a few models of neural network, and they showed us a demo with, I can't remember, there was some number there, 500 cats recognized per, I don't want to bluff now, but it was a matter of seconds. And they were showing us like basically a picture on the screen, and this is, that brew of cat and so on and so forth. And it was amazing how fast it was running. So yeah, they seduced us, and they left us there in the middle wet without knowing, what we had in our hands. And then we realized that they launched a couple of years after Google Photos, and maybe a few months after TensorFlow and the likes. And yeah, then DJI came, the drone manufacturer, and they said, we want to look at your chip and we want to run a few examples. And actually it turned out that they were recognizing water. They had no means of sensing water for their drones, and the only way to do so was to use a camera and use a model to recognize the kind of foggy, transparent sort of water, let's say, texture. So yeah, that was in 2015. In 2016, Intel came and said, we want to look at your technology and so on, and they eventually bought us. So that was 10 years ago, plus or minus. And back then, yeah, we thought, that was just a small feature in a big product, doing some, kind of collateral thing. But yeah, these days we think this is mainstream, and it's happening. And I think we have seen only the surface of the thing. And before I'll give the microphone to the next presenters, I just want to tell you that if this happened 10 years ago, and what we were having for the first time on a mobile phone or a mobile platform, a drone, something running on a chip, kind of on a battery, and then 5 or 10 years before iPhone was launched, and today we talk about amazing kind of large language models and stuff like that. What makes you think that in the next 5 years you won't see another big bang from a new technology? And I think something is already cooking. And just to give you a snippet of what's going to happen, I work for an Irish company. part-time, and they are the same guys who did the chip years ago and tested by Google, and they work and play now with the electron, as you know, the particle that carries the information, and that's called quantum information and quantum computing. So so that if that's going to happen, we are in a totally different planet, world, and so on. So yeah, I'd say watch these things happening these days, and believe that we are witnessing history here. And one more thing, I think we have all the ingredients here in Timișoara to actually contribute to all of this as we did before. And it's important to focus on the right things, the right applications, and carry on delivering good things. So thanks for coming. We hope that this is happening more often and with sense and focus on good stuff. Okay, so thanks for the attention now, and I'm going to hand over to Mihai for the presentation, then Bogdan, and at the end we will take a few questions, and we will collect a few and you will answer on the podcast at the end some other questions. So we take a couple of questions here live and then in the podcast the rest, okay? Thanks.
Thank you, Val. I need a clicker, yeah. Actually, a funny story. I don't know if Val knows that, but in 2019, I had a company in California, and we were using your chips with the Intel suite very, very nicely. It was the best benchmark for image recognition as opposed to the Microsoft stack. That's 5 years ago. So yeah, I know your technology very well. Does it work? Do I have to start it? Trebuie să apăs lung? Pe ăla de sus. Pe ăsta? I-am dat pe next. Imediat. Dăm un reset și merge. Ubuntu. Seems to be working. Let me try it. Okay. Good. I don't know how much time I have. 35, 40 minutes? I'm looking for... Okay. 30 minutes. Okay. Good. My name is Mihai. I come from a company which was established in Timișoara 18 years ago. We have a private equity which bought the majority stake in our company in October last year. And now I'm part of a larger group of companies. I'm still responsible for the Microsoft technology products and services that we do throughout Europe. I don't know, 200 people doing Microsoft stuff today. And as a track record for 18 years since our existence, we've only been working in Romania with the Microsoft technology stack. So we know it pretty well. Me, just as a side note, I'm a software engineer. I worked a lot with the Microsoft Cloud, re-architecting apps for cloud. And in the last, I would say 4 or 5 years, I'm doing AI projects. Myself, not so much, since I have 60 people doing that. But I'm involved in thinking about the next products, next services, how to implement them, and so on and so forth. So this presentation comes from some experience. 6 years. This year we already have 6 different AI projects that we've done or are in the makings, right? As opposed to 5 in total in the last 5 years, right? So there is a curve, I would say, which is growing exponentially. So part of what I'm talking is our experience, and part of what I'm talking is based on what I read to try to understand where this is going. And that it's indeed going to be a big revolution, and going to try to explain how, why, and so on and so forth. Just a bit of context before going into, I would say, most generative AI. I don't have time to do AI in general. I'll try to explain the difference and so on and so forth. We started in our company with a very basic question a few months ago. will software engineers be replaced by AI? That's the question that we asked. 6 months ago, we said, no way. 3 months ago, we said, actually, actually, we have a problem. And yes, indeed, if you talk about a full cycle of developing a software, enterprise software, it's much more than coding, right? And you can argue that today AI can help you a lot here, writing code a bit faster or documenting code and so on and so forth, whereas all the other aspects are very human intensive. That's my take today. So yes, indeed, I'm clicking again, but I don't know why it's not working. I need some help with the clicker. It did. Okay, I need patience. So today, indeed, AI still helps us here. Or it will improve, I don't know. I see some measurements that, for example, GitHub Copilot, I don't know, increases the speed or efficiency by 20, 30% or whatever, different numbers, right? And you can argue, yes, but that's only in this phase, and that's, just a small part of a big thing what software development means. Yeah, but that's today. And the evolution is very, 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 very fast. Just to give you a little bit of context around that, here on this chart, you see it's not the correct benchmark, because on the right-hand side, you see LLMs, large language models, whereas on the right-hand side, the other way around, on the left-hand side, you see an agent, which is something very different. I'll try to explain the terms a bit later on. So Devin is not an LLM, is not an assistant, it's actually an agent who aims to replace a human in a specific task, right? Today we have agents who are able to do 14% of the tasks that they are assigned. Meaning you come to work in the morning and you go into Jira or your preferred project management tool, and you understand what you need to do, and you do all those things, including pushing into main or whatever you need to push into, documenting, and all the tasks that you can imagine as a developer. These are done with a 14% completion rate by Devin today. That's already a few months ago, right? The speed is quite high, I would say. So I would expect just a few iterations where the number becomes relevant. So my take today in our company, we say that if you're a good software engineer, AI will help you be a better software engineer. If you're not a good software engineer, you're going to be replaced, right? Now, this is a bit of a simplification, I would argue that. And that's, in my opinion, that's only on the short to medium term. I don't know what that is, just a few years maybe. And I think that long term, because of AI and its evolution, much more jobs are going to be unlocked in areas that are not addressed today by software. And that's going to be part of my statement later on. Why is it that? GitHub, we already use it successfully in our company. Not all the people. We just said, we're going to give a license, a GitHub license, to whoever asks for it, because that shows intention, right? And anybody who asked for received one. We didn't automatically give a license to everyone, because whatever comes free is not valued enough. But yes, there are different numbers which say that people are happier and more efficient with the GitHub Copilot writing code. I do it myself every week, and not every day, and it's still very, very good. Okay, now let's go to Microsoft. I'm very much involved with Microsoft in multiple capacities. I run a company which is a Microsoft partner, so we implement their technology. I'm also an engineer and Microsoft MVP on Azure, so I'm also a technical person. As a businessman now, I'm trying to look at what they are doing. And in the last, I would say 3 years, their cloud adoption has increased, has decelerated. So it's still an increase year over year in Azure consumption or selling, but it has decreased. So that was a business problem that they needed to solve, right? They happened to have this initial investment in OpenAI. So it's also some coincidence, but it's also some planning. And because of that very big success of OpenAI, I would say, they decided to go full throttle into the AI world. When I say full throttle, they have designed their own chips. They are committed they have committed over 200 billions in per year in investments. So just to give one example, they announced Stargate, which is going to be a cluster dedicated to train LLMs, and that cost 100 billion. It's just one cluster, right? They are building Azure with the same rate per year, approximately 100 billion per year investment. So this is just in hardware. I'm not talking about Microsoft research. I'm not talking about other investments. I go to Microsoft every now and then to Redmond, and this year I came from there a changed man, right? I went there, as I've done in the last 15 years, every year, discussing with the commercial people, with the business people, with the technical people, just to understand their plans. And this year I came and I said in my company, I said, guys, it's going to be a big revolution, so we have to change fast and we have to adapt fast. And that's when we started to have our first AI project this year, actually in March or April or something like that. Why did I change? Because I saw these numbers, but also because I saw the people inside Microsoft who are running the business today, and they are entrepreneurs, most of them. So they are people to whom the CEO said, you have a carte blanche, you just go and build a business. I don't care how much you spend. That's the reality. After 15 years of seeing a different world, now I see this, okay? So that's my context. Going to AI and more specifically to generative AI. I like this quote very much. I don't know who said it first, but you know that something major is happening if you see updates every day or every few days, not every few months. And that's the rate of the evolution in AI in general, right? A new LLM comes, a new version of an LLM comes, a new agent comes, and so on and so forth. Every few days, you see something brilliant. Now, let's start from the beginning and try to understand where these come from. Well, you can argue this is not the beginning, but let's start from here. This is what made AI attractive to the world, because with ChatGPT, with the application, everybody understood that AI is a big thing. Our customers, their users, and so on and so forth. So it's easier to talk about AI now since ChatGPT. That's the reality I see as a business person. It took us as a company 6 years from our first Azure project to really make a lot of money from Azure. 6 years, because we had to convince so many people of so many things. Now, when we enter the door, they're already convinced. They already know that AI is cool. It's just a matter of understanding where to invest and where not to invest. So we already passed a few months of hurdles in explaining a lot of, fears and so on and so forth. That's because their children use ChatGPT at home or at the school. Okay. Coming back to the Microsoft technologies, the biggest, maybe you know that OpenAI service hosts the LLMs which were built by OpenAI. I'll come back to that a bit later, more technically. But the Azure OpenAI service has one big customer, and that is Microsoft. And that shows me also another thing, which is the way they approached it. So Microsoft has, I don't know, probably more than 10 co-pilots today. They have the Microsoft 365, the GitHub, Windows, and so on and so forth. They have decided not to have a co-pilot team which does the integration into all those products or product families. They have just told their product teams, you go ahead and build your own co-pilots. We don't care how, okay? That also shows me that the need for speed is that big. I mean, they traded off, right? Traded speed and adoption versus quality to some degree and versus architectural integration. And when a big company like this says, I want to ship something which is 80% perfect, and I don't care how much it integrates into other similar products that I do, that shows me where the market is today, okay? And that also shows me how to approach this with customers. Because you can tell the customer, our customers, hey, I know it's 80% perfect, but you have to start adopting now, because in 3 months, in 6 months, you're going to have very big updates, very surprising updates. And if you don't, your competition does it anyway. So that's the discussion that we have with, just in a nutshell, with our customers. Just having fun with asking the PowerPoint Copilot to make me a slide about Microsoft 365 Copilot pricing. So this is generated in my PowerPoint Copilot, as you see here. This is a print screen of my desktop. And this is another slide which the Copilot in Microsoft 365 generated for me. I wanted to put these very, very simple slides just to showcase a few things. First and foremost, they are very useful tools for very simple tasks. That's today, again, right? They have, I would say, niche cases or specific cases where they are not very useful. So that's the typical conversation that we have with the large company that we try to sell AI into. Yeah, but Copilot sucks. Yeah, but we don't do Copilot. Yeah, but and then we try to explain them. Look at the dynamics. Look at what happened in the last 6 months, last 12 months, and so on and so forth. Some other example of doing a summary. No, this is actually generating something like a presentation about my company. And it's all valid. It makes a lot of sense, but at least a big paragraph is not true. So it hallucinates, and in a way which actually makes a lot of sense. You cannot know unless you actually know that information. I'll come back to that in a minute as well. This is another example of a sample psychological profile in Romanian, which is summarized in English. And the summary is perfect. I mean, I really like it. It makes sense. That's already being done. Now let's go to some, I would say, taxonomy. Let's try to define a few things here. I'm pretty sure that most of you know most of these, but maybe not all of these. So let's try a few minutes. ChatGPT, which is an interface, it's an application which is on top of the GPT large language models. And then you have DALL-E, Sora, which generate videos and images, respectively. They are being developed by OpenAI. What is a foundational model? Anybody care to venture a definition? Okay, I'll try. It's a very large model, meaning it has been trained on a very large set of data, and it can be used as a base model for further fine-tuning, it's called, further training for your specific needs. That would be a very approximate definition of a foundational model. Large language models are a particular case of that because they treat or they deal with words. And ChatGPT has a large LLM behind it, okay? How do they work? Well, they are designed to generate new content. Based on what? And that is the key element. If you grasp this, you'll understand what they cannot do and what they can do. They try to predict the tokens. If we're talking about words, about LLMs, then that's words. The tokens which make most sense after the input that we give them in a pure statistic way. Okay? So if you go to ChatGPT and if you enter a question, it seems like it's answering like a person. It actually gives you the words which make most sense probabilistically after the input that you gave it. Now, if you have the time, you don't have to, because I'll show you a lot of examples to play with different LLMs and different settings of those LLMs. You're going to see that the outputs can vary a lot from an LLM to another, and for the same LLM of the same version. Okay? That's why we call them non-deterministic. So LLMs by design are non-deterministic. That means that if you gave an input, you receive an answer. You gave the same input the second time, you might receive a different answer. Okay? Make sense? It's still probabilistically valid, but it's not deterministic, which opens up a huge discussion about the applicability of LLMs or the limitations around LLMs and what do we have to do in engineering afterwards to resolve those issues. Of course, they hallucinate. They can hallucinate, or the term that I use mostly, or I like mostly, is they fabricate stuff, because hallucination actually gives like a human-like attribute to something which is not human. So I would prefer to use fabrication. They fabricate stuff depending on the implementation of the LLM. So for example, in ChatGPT 4.0, that is quite low in terms of you can set different parameters to guide the LLM into answering without fabricating stuff and to be as close to deterministic as possible. But both such parameters are not a guarantee that it won't hallucinate or that it won't be a bit non-deterministic, okay? Hope it makes sense. So they don't really understand. And a very simplistic explanation, further explanation of GPT and LLMs, yes, LLMs are basically very large foundational models trained in deep neural networks, using deep neural networks. For example, the large LLMs are trained on a few tera of tokens. Tokens are almost individual words or series of characters which make sense in a sentence. You have to visualize it to understand how tokenization works. The whole internet is 70 tera. So how much is that? 70 trillion. No, it's not trillion, it's more. No, 70 trillion of tokens. That's the whole internet, right? If you would reduce it to its simplest form, some would say that in between 20 and 30 is the whole data, okay? And the large LLMs are trained on 15. I might be wrong about some numbers here, but not about the order of magnitude. So you can arguably say that you're very, very close to actually finalizing the internet data in terms of its as a source for LLMs, okay? So how do they work? Based on the input that we give, it will generate the next probable words based on what it was trained on. And of course, we have a lot of limitations today. For example, when you ask ChatGPT something, you have a limitation of number of tokens that you can send. Basically, the length of the question or the input is limited. In any LLM is limited because of size, because of memory, because of cost in the end, right? You have another limitation, which is, yeah, but most of that data is junk or is repeatable or and so on and so forth. Yes. So there are a lot of areas to unlock potential evolutions of LLMs. Until now, I would argue that LLM training was a brute force approach. We take a larger computer, big enough to train on the whole internet data, right? That was the approach so far. And we're kind of getting close to the limit of what we can do with this approach. Okay, now let's give you an example of, or a snapshot of what happened so far and what is a reasonable prediction of what will happen in terms of efficiency, you can say quality of LLMs, in terms of, I use the order of magnitude as a metric. So GPT-2 was like a preschooler in terms of intelligence. I don't like to make equivalents of human intelligence, but it's useful to understand. So when you would ask GPT-2 something, it would understand the words as a preschooler would. GPT-3 is like a, I don't know, elementary schooler, and GPT-4 is like a smart high schooler, right? That would be a rough equivalence. Why is it important? If you give GPT-4 a test in math or anything which is in high school, you wouldn't make a difference between the mistakes it does versus the mistakes that a human does. So in terms of a specific test, math, algebra, etc., you wouldn't make the differences, okay? You wouldn't be able to tell, right? Just reading the answers. It's as accurate as the smart high schoolers, okay? How can I tell the difference between them? You need other mechanisms, okay? Okay, this is what we have so far. And if you look at this graph, this is the effective compute. So how much compute it was used to train them. That's already happened until today. And that is the evolution so on from now on. So you would expect that in the next 4 years, that's a 6 orders of magnitude increase in the actual compute allocated to train the next versions. Okay, so that's 1 million. Okay, that's a lot. Okay, now let's go into details. In terms of progress, there are at least three big areas which can unlock some efficiency in what we can expect from LLMs. One is compute. One is algorithm efficiency, and the other one is unlocking other scenarios, which, again, I said, we only approached it in a very brute force manner, okay? In terms of compute scale, you can argue that it's 2, maybe 3 orders of magnitudes every 2 to 3 years. I already said that. I have some data to back this up. This is the largest effort the US is making in terms of allocating capital for a single industry. It's much more than Project Manhattan, the one that, delivered the atomic bomb. So in terms of scale of how much capital is allocated, this is much more than anything we have seen, okay? And this is just the Microsoft story. All the other big vendors, like 2 or 3, have similar stories, right? In terms of algorithm efficiency, I'll just give you an example. Quality of data, but the algorithms themselves, or the mathematics behind them, actually, and this is guesstimating, 1.5, maybe 2 orders of magnitude every 3 years. Why this is guesstimating? Because a few months ago, the big publishing houses, the big research centers have stopped publishing their research. So until 1-2 years ago, all of them were very, very public about the algorithms, the data they use, and so on and so forth. They kind of stopped doing that last year. Okay, so now you can estimate something. And this is coming from a book written by a guy from OpenAI, who's actually doing this, okay? So algorithms efficiency and other methods. I'll give you a very simple example. Like the LLMs today, you give them a question, they give you an answer. You can already apply it in real life, like things like reinforcement learning with human in the loop. So say you want to understand how to create a new company. And let's imagine you have an LLM, which is trained on, or which is looking at the data coming from Registrul Comerțului, okay? And you say, I want to make a new company. And it will give you an answer. Reinforcement learning means you asking subsequent questions, which are guiding it through to what you actually need. So you actually apply new prompts, that's how we call these questions, new prompts, which are much more narrow and more specific to what you actually want. You can already do that with public applications or trained LLMs today. What I'm talking about here mostly is using this technique in the training phase of an LLM. So that's already being done, okay? You need much smaller data sets, and you can apply things like this, or chain of thought, or other mechanisms. There are dozens of approaches to actually make it learn while it's being trained, with the human in the loop potentially. In terms of going back to how do we apply it, how do we implement it in the real world? We use it in our projects. So the LLMs that we use are coming from OpenAI, and they are being hosted by Azure OpenAI Service, because that's one of the hurdles that we have to explain though with our customers. Okay, what is my guarantee that the data I send, or my data, is not being used to train the LLMs? And we have to explain that, and we have to show them. But it's easier when you have a technology which has the governance and the security already set up. So it's very, very clear to show to the customer, this is where your environment is. Only you control it. This is where your data sits. It goes to the cloud, but if you don't want to, it doesn't have to go to the cloud. That's another topic, and so on and so forth, right? So that's why we use the Azure hosting of OpenAI models. Now, how do we actually apply this knowledge with a real company? So I'll give you some use cases that we have worked on or are working on today. Understanding the rules of admission to a university. So imagine, instead of calling the secretary, hey, my kid just won, I know, a few years ago, the second prize in Olympics in mathematics. Does he qualify automatically to, and all of that stuff. So narrow cases, you simply take an LLM and point it to the methodology of admission, and you have a web interface and people interact with that. And that's going to be in production next week, actually, to a large university here. anything like glorified search with enterprise data. And I'll give you an example, an assistant for a banking app. So you have a mobile banking, like one of the new banks. You have a mobile bank, and you ask there, how can I take a loan? Okay, nice. That will simply navigate you through the manuals or the hidden aspects, areas of the application. But you can also ask, I have this amount of land, which is where I cultivate this specific plant product. This is in agriculture. How much credit can I take? And it will answer you. And the answer is based on a lot of methodologies, a lot of documents, which are inside our customer's environment. Okay, and so on and so forth. With the private equity, we are the one that bought us. We're doing an M&A, an LLM for them, on AI for them, to actually increase the chances of a due diligence to somebody saying, yes, we want to approach you, by understanding and clustering different companies from around Europe based on the distance that they have from companies already in the private equity. So there's a lot of generative AI there, but other algorithms as well. How do you do that? Well, very simple. You start from a model. In our case, it's Azure, because that's what we do. And then you can do prompt engineering, which is another job, like data scientist, almost. Then you can do retrieve augmented generation, and then you can do fine-tuning. And very, very briefly, I want to go through all of this. There are thousands of models you can start from. You need to play around with a few just to understand the differences between them. This is an example of prompt engineering. This is just the setup. This is Python code, which is linked to an Azure OpenAI service, which has a specific model deployed. And then I can play with it. I can send prompts to it, like there in the right bottom. This is I would say, the landscape of a prompt engineer. Okay, these are all specific tasks that you need to do. It's like another job. It's going to be in 1 or 2 years. Okay, we're going to send you the slides, so don't worry about taking the perfect picture. Prompt engineering, this is how I can ask it. I need to understand the explanation behind mathematical operations. As you see here, this is like metadata I sent to the LLM. And the actual prompt is, how much is 2 plus 3? If I wouldn't have put that, it would answer me 5. But because I put that context, that's called completion API. I don't want to go into too many details. But then I have the whole response here. Mathematical operations are procedures, rules used to manipulate numbers, la, 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 la. And in the end, it answers that, yes, the result is 5. But I require the context, okay? I think I have better examples or other examples as well. Yes, this is another example. I'm a mid-school student. How much is 2 plus 3? And it's a totally different answer, which is like, you, the LLM, are a mid-school student, right? Like you're in the 6th grade. This is how it would explain. Two other examples. You are a high schooler. How does gravity work? And then I give an example. And here's how it explains to me. Airplanes fly due to a combination of 4 main forces. You are a physicist. How does gravity work? And it's a much longer, more complex explanation. So just to showcase that there are a lot of tools, and I haven't showed all the techniques, to basically guide the LLM onto towards how it will answer you, okay? The next thing is retrieve augmented generation, which is a software pattern, very, very simple. If I want to use the generative AI, the power of generative AI on top of my company data, like the use cases that I gave you a few minutes ago, right? What do you need to do? You need to index, like a document search, on top of your company data. You need a vector database in the end, on top of your company data. And then on top of it, you put the generative AI. So instead of people looking into different apps and files, searching in folders for data, you would simply say, I have this interface. I need to understand what is my company medical insurance plan. And it will know where to ask and where to pose a query, basically in a vector database, in a document search, and give you an answer in a natural language. And this is very important. I want to stay 1 minute here. 3 months ago, 5 months ago, I didn't see the importance of that. I said, yeah, but you just have to search and read. Well, people don't function like that. And I would argue that generative AI and large language models themselves are opening up a new way of doing computing or software. Until today, we have built software for engineers mostly, because all the user interfaces that we have built are with tables, charts, forms, and all things where you need to input data qualitatively and quantitatively very, very accurately, I would say. People don't work like that. So if you expect that somebody would, I don't know, save their house from a fire or their valuables from a fire because they read the methodology, people don't do that. People just want to ask, what do I do now? And again and again, this is a very simplified example. Like understanding the methodology for admission, that's 78 pages, 75 pages. Who reads that, right? And then all the examples can be extrapolated a lot in the enterprise context. Like a use case that we've done is in HR. Give me top 5 people with SAP experience and which are managers in the sports industry. Now, good luck doing that kind of search in a CVS database, okay? And so on. So the examples can go on. So this is applying, as simple as that. This is an example of, it's a web application which puts an LLM on top of conference articles. And you can ask them, information in those articles, and it will answer you with something, including a link to the specific document that the answer came from, and so on and so forth. I don't have too much time. Another example is the same kind of approach, which helps a teacher grade papers. The use case is understand the summary of the research paper and see a correlation of that summary with the bibliographical resources used in that, and if they're relevant or not. Okay, this is a use case. So many people spend so many hours checking that. A lot of AI fears to conquer. I don't have too much time. I just want to list them here briefly. Some of them have answers. Some of them don't have answers yet. It is a very immature field. So people like big companies and officials are working to standardize this domain, which is very hard to standardize because it's moving very fast. I have a joke here that we in Europe are very good at, regulating what the US are building or the Americans are building. This is very true in AI. This is very, very true. I don't say we don't need legislation. Yeah, we need the legislation, but we need to move much faster because the technology is already here. And things are happening already. Like, how do you find out fake content? Yeah, there are solutions for that, and so on and so forth. I don't have too much time. How can you unlearn an AI? That's also a very big thing. What is the future? And I'll stop here because I'm past my time. We are at 0.0001% of what AI will be doing in the next 5 or 10 years. So we're extremely low. We are talking about large language models and maybe do some retrieve augmented generation with our own data. And maybe we have some assistance. So I'm still doing the work and I have something which assists me in doing that. But work is already being done into building agents. Agents are things which are doing the thing instead of a human, right? And then we're already seeing work being done in multi-agent systems, which is closer to AGI. If you want my take on AGI, like artificial general interface, the definition would be something which is as smart or maybe smarter than humans in a broader set of cognitive tasks. An LLM will never be AGI. An assistant will never be AGI because it's very narrowly focused. An agent is potentially as smart as a human in a very specific task, right? Multi-agent systems will be towards that. We still need some work to do there, but we already see from vendors like Microsoft, APIs, SDKs, if you want, to build agents and multi-agent systems. So there's a lot of work being done in those areas. Basically, today the limitation is still compute, because the big difference between an assistant and an agent, the agent knows intent, and it has a lot of memory to remember, to actually think about the task, not for 10 seconds, but maybe for months. So that's a totally different ballgame. It needs another approach, but things are being built towards that. I don't think I have too much time, so I'll stop here because I can talk until tomorrow. And we're gonna have questions at the end, right? Okay, thank you.
Thanks a lot, Mihai. Yes, and for those who don't know, I have a full-time job somewhere else in the city hall. I don't look like it, but just to tell you a story, before we had the elections, we had a version of obviously the OpenAI model on the content of our site, and we showed that to Dominique and said, like, we are going to launch it, and he said, chill down the jets, like I think it's just a bit better than the Google search. So we work on improving the content to give to this model, so that we satisfy the mayor to launch our new product. So yeah, it's doable, it's there, we have it. It's just that we have to convince the mayor about the quality of the answers, and obviously the quantity of hallucinations. So that's what we work on. So yeah, next I'm going to invite Bogdan Berchan, and he basically works in the health sector, and basically we know him for 5-6 years now. We kept on investing, mentoring, and so on and so forth. So XVision previously, now Rayscape, and well known at national and regional and European level, working on that. Yeah, so good news is that hospitals open the doors, and you get data for that. So thank you.
Thanks, Val, for the kind introduction. So first of all, just to make things clear, I'm not a business person, as Val and Mihai are. So I'll just try to match at least half of their presentation skills. The pointer, please. Okay. While Mihai talked awesome insights, especially on the LLMs and what's happening on large language models, as you will see in the following minutes, I will be referring more on complementary side of artificial intelligence, which is computer vision. Usually, what's happening cool in AI is happening first in NLP, natural language processing. This is historically, and this has happened with large language models as well, which eventually turned into those innovations, those core innovations, turn or inspire innovations in computer vision as well. So there's a bit of lag there. There's natural language processing, there's general computer vision, and there's my domain, specialized computer vision, specifically medical. So first of all, a little bit about ourselves. So Rayscape is an assistant for radiologists. That means we aid them with a suite of artificial intelligence algos that we built in-house, similarly to how a peer colleague of them would be by their side 24/7. We are a team of fairly young still, 20 people or something. And we started this, I think, in 2018, when 4 of us were still in the 3rd year of our engineering degree in Polytechnica University of Timișoara. But since then, our expectations, our goals have increased, have expanded. As Val said, some hospitals gladly open our doors, and Romanian radiologists know and use today our technology, And this is starting to happen. We start to see the same in the neighboring countries, and we just started as of this year looking into clearing the FDA as well. Well, I was telling you we are doing a suite of artificial intelligence algos. What does that mean? So in computer vision, there's tons of different specific tasks that can be done. There's object detection, right? So localizing the disease, the location of each instance of the disease. There's classification of the disease. There's segmentation of the disease, segmentation of the organs. There's even image-to-image translation. So basically generating synthetic images such as bones suppressed or bone subtracted tissue that help radiologists better see what's hiding underneath the traditional X-ray. And we'll be coming back to this slide after we talk a bit about what generative AI means in computer vision. So we do that on traditional 2D imaging. So like any other image that we take with our phone, there's the traditional 2D X-ray, but we do the same on 3D imaging, such as computed tomography, which proves to be way harder than it sounds. Right, so if a traditional 2D image is way more complex than text is, the 3D imaging is way more complex than 2D imaging, and there's quite less literature on that, and there's quite a lot more room to explore on that, on this direction. So there's lots of research potential here to be done. We do that on static images, so one single image at a time, and we do that on dynamics. That means we look at the same patient in time. So we pair different scans of the same patient, so different 3D volumes, if already a single 3D volume wasn't hard enough. So we can look and tell radiologists quantitatively how for example, the treatment for their cancers progress or regress. So basically, we look quantitatively at the evolution of different potential lesions in those scans, and to match each lesion in one scan with a lesion in the other proves to be a way harder task than it sounds. It's called image registration. So what I was trying to convey is that there's a lot of different flavors of computer vision. Similarly, how there's different flavors of artificial intelligence. There's natural language processing, there's computer vision, there's audio, there's many more. And in order to progress on those, a lot of research is needed. So in a startup like ours, one core of daily operation proves to be actual research and development into not only building the algorithms, but also validating those algorithms, be it in clinical practice or not. So this builds us credibility in front of our users or potential users, or in front of investors. So research, what I want to say, the bottom line, research is very important for an AI startup, especially all the more in medical imaging in healthcare. Right. So we are currently something in a transition phase, similarly to what we've seen in general artificial intelligence. There has been a paradigm shift. So we've all heard about the new wave of AI algorithms, the new rapid advancements, and so on. What does that mean specifically in computer vision? So if I was I presented you all those different tasks earlier. Those are modeled using different technologies, different neural network architectures, different convolutional neural networks or generative adversarial networks, or different kind of technical stuff that I'm not going to go into, but it's important to understand that it's different stuff. And this is even more so when we jump from computer vision to natural language processing. So for example, if you ask me a computer vision guy to understand or even build a natural language processing algorithm, it would be at least very hard for me to do so if I manage to do so. So that kind of was the usual up until very recently, when the mighty awesome transformer showed up. The transformer is a new type of neural network that what it achieved was to unify all those domains. So if basically before all of us researchers had to somehow specialize, niche into all these different branches and flavors and subtasks of artificial intelligence, well, now the transformer can do them all. That is very impressive, and that in turn accelerates the rate of growth, the rate of the rapid advancements that we are already seeing in the domain, right? So basically all the researchers got together, shook our hands and started working basically on the same thing. Yeah, so I was telling you we were somehow in a transition phase. That means we still not switched to foundation models. Foundation models would be capable to tackle all those tasks that I was talking before at once. So the same model would do them, the same transformer basically would be able to do each one of those. We are not. Which one? GPT-4o? Yeah, GPT-4o is a transformer as well, yeah. Basically, all foundation models are transformers today, yeah. And please, if you have any other questions, you can address them at any time. Yeah, so I was saying that we are still at the RayScape, not in that phase, and medical imaging, as I was telling you before, has a little bit of lag. There is not yet any foundation model that reached medical imaging, but we already switched to transformers. So basically, all our current algorithms are transformers. It's just there's one transformer for each task at the moment. The next step would be to get one single transformer that do them all. So the transformer impresses not only through versatility, which is a specific trait of foundation models, but also through specific task performance. So it would beat every independent old model at its own game, basically. So that's why this new generation of AI algorithms are so cool. I was mentioning quite a number of times research, us doing research, but we're not alone. So I don't know whose quote was that. I heard it a while ago and stuck with me. The thing is, technical development in startups seem to be, at least in AI startups, seem to become a lot more advanced. You need to understand a lot more math, to read a lot more papers. My peer researchers are, if you want to be a good researcher, you, if not read research articles on a daily basis or every day, at least skim a few every day. So there's such an immense quantity of information published nowadays that we as researchers don't have the potential, the bandwidth to stay up to date with all the cool stuff that's showing up, and we could potentially try and integrate into our startups. So there's at least I've seen an increase in the number of collaborations between academia and startups, an increase in number of spin-offs, and ourselves as well. Every time we look into publishing a paper, one of the first things that we do, we look for a partner, be it in academia, be it a hospital, a partner that has a strong research background. Yeah. So Mihai touched a little bit on taxonomy. He explained very well what foundation models are. I could not have done it better, but I want to complement here a little bit. on generative models, generative AI as well. So I think it's a very common misconception that's way too easy to make nowadays, that all this new craze, all this new AI boom that we've seen, and all the advancements and cool large models, we can call it the generative AI, which actually Google does not help either. This is a search I did yesterday, which could not have been more wrong today. Foundation models are actually not, objectively, are not a form of generative artificial intelligence. So why the smart guys at Amazon said that in the first place? It's not because they didn't know what they were saying, but the guys that wrote the blog post probably were right at the time they wrote it. It was probably a perfect snapshot in time at the moment, but it's not true anymore. When talking about the first foundation models, which are actually the bedrock of this new wave of cool models, right? The first of those were in natural language processing. So the large language models, which were actually generative networks. So all the cool new AI at that point was generative AI. All the cool foundation models were generative models. Yes, that's true. But when things switched to computer vision, that was no longer the case. This is Dino. This is a model released by Meta AI, which is one of the coolest existing foundation models on computer vision. Basically, this model haven't seen any human annotation. It learned intuitively, similarly to how GPT learn. So basically a form of self-training by seeing large amounts of data with no annotation and just trying to make sense of all of it and trying to extract useful features from that data, from that image type of data this time. This has nothing to do with generative AI. This has no generative techniques inbuilt into training, which are clearly defined in AI. Still, it's one of the most powerful existing foundation models today, and it's leading the new craze of AI developments in computer vision. So I think it's worth noting the difference, and this kind of foundation model could do all the tasks that I was mentioning we're doing at Rayscape, except it does them on general computer vision, non medical, because it happens in medical data, basically. But given it would have seen medical data, it could have done all the tasks that I was telling you about earlier. So back to the earlier slide. So this is a feature, the auxiliary visualization is a feature that we put out something in 2018 or 2019. And this is actually generative AI, although it doesn't belong in the new wave of artificial intelligence. So how come so? Well, not all generative AI is a foundation model as well. So generating content doesn't mean you're using a foundation model, right? So it actually uses a type of neural network that's called generative adversarial neural network, right? So it's in the name. And the network was introduced something in like 2014, so almost 10 years old, and it's generative AI. So I think it's a very important distinction to be made, and it's one of the biggest misconception or mismatches, misnomers in this new craze of AI. And this probably has been driven by the fact that users, the general mass users, interact only with generative models, right? If they see Dino, they wouldn't realize it's part of the new AI because it's just a computer vision model that does what the other models have previously done, right? It's not generating cool images or cool text that are doing our homework or so on. So the bottom line is, if we really want to jump on the buzzword train, at least let's make sure we use the right buzzwords. So if you're into memes as well, I think one other thing that needs to be updated with this new AI wave are the memes themselves. This is actually a meme that a colleague of mine sent me, Stefan, sent me. What did I do? How do I go back? Sorry for that. Yeah, so this is actually a meme that a colleague of mine sent me last week, and I laughed it off, and I realized this is so 2020. So I fixed it like this. It's with all the changes that's happening in this industry, I think this is a phenomenon worth mentioning as well, as it's getting increasingly more difficult to differentiate between those startups that are actually building and researching the frontier of innovation in artificial intelligence and pushing that frontier further, and those that are integrating actually an API and are just basically users of models. I'm not saying one is better than the other. I'm just saying it's a distinction worth knowing. And yeah, if you're are an investor, you really need to look into that. I think this is further propagated or taken advantage of by big tech by making you believe on purpose that you're building AI if you're actually just customizing an API. I cannot, or I won't point fingers at startups here, but I've seen it firsthand myself on a smaller scale when, for example, I was a jury in HackTM, and a ton of teams there basically bragged loudly about their core AI component and how they build the AI component, when in fact they use a graphical user interface to just fine-tune, customize the API. And it's really not the same thing. It's, to make an analogy, is like choosing the finishing touches in your newly bought apartment does not mean you build the apartment, and does not mean you're having a construction company, right? So be aware of what kind of AI startup you're talking about. This is especially important if you're talking about technical differentiation. This is the part where I'm not agreeing with Mihai. It's about open source software, something that OpenAI has chosen not to do, exactly like he pointed out, at some point. For financial reason, I'm not to judge that. It's just smarter people than me are arguing nowadays that it's harder and harder for an AI startup to keep a technical differentiator, a technical algorithm as a moat, since the increasing power of the open source community. And this open source community is not just the average Joe or the small Rayscape company, right? It's it's covering even large players, big tech companies like Meta AI, for example, which published Dino open source. They basically pledged that they go full open source, and they did, and they pushed the AI field way forward, and they're not the only one doing that. So every time a new GPT comes up, also a new Llama and other similar variants of large language models, similar in performance, show up, and yeah, they are open source and free to use, and are paid with by developers. So it's harder and harder to argue that you have a moat in a mode that you can keep long term on actual AI technical development at the pace that the open source community is moving these days. On the other hand, I would argue that data might be making a return. So I saw it in 2017 in The Economist, an author that was saying that data is the new oil, because the now old, but the new generation of AI algos were benefiting by more data. The problem with that is kind of faded away, because people soon realized that there's only so much resources that we can put into having human effort manually labeling, training data for those kind of networks. And you would quickly reach saturation, or a point of that doesn't is not going worth going past that. So now with those foundation models, they basically unlock self-training on unlabeled data, on never seen amounts of data before. So totally different scales of data. And yeah, it's harder and harder to get that much data, especially in sensitive domains such as healthcare, which I think is actually one of the reasons there's still no foundation model in healthcare. So data is a huge bottleneck there, be it unlabeled. Anyway, so I would argue that data is making a return as a moat in startups these days. Yeah, one of the last things that I want to touch is a message from a startup founder to investors in the room on how to not do, how to not make due diligence, and how not to investigate these kinds of aspects in an AI startup, based on what we've seen on our personal experience, be it in actual due diligences or just technical interviews while fundraising, right? So just the three things that I want to touch about. The first is asking for code snippets. We were asked to provide actual random code snippets, and that happened actually this year in the era where Copilot exists and generative code models exist, and just shows it's not only pointless, but in my opinion, I think it shows the investors are not aware, at least, or are not caring about the state of the technology that the very technology that they actually want to invest in. Second is the actual auditor. Not a single time we got to be audited by an AI expert, which actually was an AI expert. It's just not in the right flavor of AI. So I was telling you, I would not be able to understand properly or judge properly natural language processing, although it's still AI. Similarly, one of the auditors that we had come in, one of the first things that told us was, hey guys, full disclosure, I've never done computer vision, and I only have some experience in tabular binary classification or something like that. And from there on, the discussion was pointless, and the investors did not did not get any value from that interaction, although he was an expert, but not in the right way. So basically, the bottom line is make sure you get the expert, the AI expert, in the right flavor. And the last thing is the very common question that you not only you are guilty of, but actually all the stakeholders and everybody in the industry, at least in healthcare, it's what is the accuracy of the system, of the product. At least when building a healthcare product, it's obvious, it's expected that people ask you. It's just they don't actually expect a hard answer on that. So how many of you would understand the answer of that question, or how well the product works if I show you the false negative rate on the X-ray product, right? Probably nobody, as we don't as we found out, and we don't even try to do that and give them actual clinical close metrics that we use on a daily basis and track when deploying our models, and are very important to us. These are actually the metrics that dictate how well the product works in clinical practice. Although what we choose to do, and it's not just us, it's everybody in this industry, is resort to a not so relevant clinical metric. Actually, it's not a clinical metric at all. It's a metric that only describes technically how well an AI network is, but it looks shiny. It looks cool, 90 something. It sounds like the model is very cool. It's very good. So we actually started this year an awareness campaign on that, Radiological Congress, in which we try to raise the awareness about this industry-wide phenomenon, in which everybody is actually publicly marketing this type of metrics that are not even clinically relevant, at least not nearly as the other metrics. So yeah, that was my point here. Instead, I will leave you with a positive example on that, which came from our existing investors. Back then, they were we just got in touch with them. It's about B-value, and they basically, instead of asking for numbers on what is the accuracy, which, as I told you, would have been irrelevant, they told us, guys, let's find a bunch of radiologists from our network. Let's get them your tool and see what they have to say about it. And that was the cleanest way, the most natural way that they could have done that. And yeah, the investment went through. Yeah, and I hope I will conclude with that, and I hope I managed to share at least a little bit of information nuggets about this current trend of AI, and I'm really expecting your questions. Thank you.
Thank you. Yeah, so my summary here after Mihai's and Bogdan's presentations are that if you are a software engineer, you're either bad and you're sacked, or you become a PhD, like in in the field. So the question to the both of you would be, what foundational models you see coming in the next couple of years, so that new products, successful products, will show up for us. Do you have a guess? That would be interesting to know where to put our money on. And for the rest of the room, if you have a question, think of it, and I don't know, I pass on a microphone and you ask the next question, okay?
Yeah, thanks. So obviously, I'm thinking every day and night about what would be the next foundation model in medical imaging. So I'm looking forward to that, and I'm actually looking into how we would be able to build that and actually gathering data for that as we speak. So obviously, I'm really looking for that. It would actually be the first foundation model in 3D imaging. There's foundation models in 2D imaging. All the foundation models now are in 2D. It's just, it would be cool to see one in 3D. It's just so much harder to gather so much 3D data. Another aspect here to add up to that would be expecting more multimodal models, right? So all elite researchers now, the big voices in our field, are saying that multimodal is the future, as OpenAI demonstrated with GPT-4o. Yeah, we should be expecting more of that. So.
Yeah, that was what I was going to say. So multimodal models, that's what we're seeing already. So there's a huge investment in that from big vendors, and the other one is a particular case would be specializing foundational models for industries, like something along the lines that you're seeing. I see an example, a different one, which is small language models. So language models which either address specifically a language, like a minority, or an industry, or not necessarily an industry or a language, but a small device that they are very performant on. The example would be Phi-3. So Phi-3 is a very, very small language model, which it's still a foundation model, but it's trained on much, much smaller data. It requires much more compute power to actually be executed, and it can run on the phone or on an on-prem device if you want. So that's another use case. What I try to shy away from, because we're different in terms of what we do day to day, we don't want as a company to do research on foundation models. I think that's huge, right? We're looking at, as an investment, we're looking at ways to integrate, to specialize, to fine-tune that into different scenarios.
Okay, anyone else with questions?
Hi. Using my investor glasses, when looking at startups nowadays, it's like everyone has AI in at least one slide. And following on Bogdan's perspective, that you either do research, serious research on the models, or you have the data to apply the models to solve a real world problem. I'm curious about Mihai's view on this, because should we invest in startups that are applying existing models and they have the data, or should we invest in startups that are trying to develop models and competing with the big guys?
So I'll go first. I have two different answers. So as an engineer, which lies towards applying existing research and then fine-tune it, maybe, so with some data science, but more engineering around it, I understand that world much better, right? So from that perspective, I would say I see a lot of use cases over there. That doesn't mean to say that there aren't in the other side of the world. And now with my investors hat, it's a bigger moat potentially if you do your own research, but you really have to find the niche or the specific area which really makes sense financially. Yeah, or a niche case, because in the first world, I see a more linear kind of return. The second word is a more of you can grow exponentially, but you can also bust. So that's my take on.
Yeah, I would just add something up to that. I think the answer or the question is not black and white. It's not either one of those. For example, in our specific case, we're now exploring options, right? So we don't have the 100 billion supercomputer. We don't have the computing capacity of some exclusive clubs that are delving on foundation model research, big foundation model research. We are aware we won't be able to do that, but the industry would move nevertheless. So what that would mean for us, where there's multiple scenarios. It could happen what happened before with the large data sets such as ImageNet, such as Coco, such as that were still not available to small scale startup like ours. We would have not been able to train our old models on the large existing data sets a few years back when we started, but we used those pre-trainings, open source pre-trainings to fine-tune our models that we build from there on top of that. So I think we are startups, even though we don't have the computing capacity to go full throttle on that as the big tech guys do. We need to build a strategy on how we expect the open source community to go forward and how we attach to that and be prepared with the necessary data, with the necessary innovations, products in place, and so on to be complementary with that, rather than just do it ourselves from scratch. If that makes sense.
maybe it's a good insight to explain your strategy on focusing on tech versus data, getting the data to train.
Yeah, so we are still researching on that. Just these days we're having calls, internal calls, and I read last week, I think, over 30 scientific papers or something like that on the subject. So I can't get you a definitive answer on that, but what I tell you is we started, as of this year, we started to gather any data that we can put our hands on. So if last year we neglected, for example, some hospitals because we know they wouldn't be paying, this year we are not, because they might be valuable in data, or we are not neglecting other modalities as well. As I said, the future is expected to be multimodal. Hence, we capture the MRIs, the ultrasounds, and so on, things that we haven't touched before. So we prepare ourselves on that front, and we try to, for now, as we build our strategy, stay up to date and as close as possible to the edge of research.
On day zero, you just start with next vision.
The thing is, when you're that small in day zero, you just copy open source. I mean, you don't do anything else. You just copy open source and try to bring it and validate it into practice. So you don't have to bother that much with building that innovation strategy, because those few people, those handful of people that you have, will be working on just taking an open source stuff, tweaking a few things at most, and bringing it into a hospital and getting feedback and iterating on that. And if you get lucky, you get data from a hospital or something like that. So I wouldn't worry that much if you're just starting. Just start and work on something.
Variation of data from sources that you put together, which might be unique, right?
Yeah, right. So obviously, as I said before, we collect all data that we can get our hands on. So if you get the chance to touch private data that could be ours, just go for it. I mean, there's no question about it. But of course, if you have just 3 people in your startup, don't get to hang up on spending your bandwidth on just that front, because it's still a volatile domain and you don't know what will happen tomorrow. So
Okay, so if you scan that code, you can ask more questions, and I think vote for them as well to bubble up. And yeah, our presenters will answer questions in the podcast after after this discussion. So scan the barcode, ask the questions, and so on, and we'll take 2 more questions from the audience. Okay.
So you mentioned earlier about the fact that the future could be tied to open sourcing, as well as basically decentralizing and not creating a data moat. Spinning back on that, wouldn't that also mean that companies would have to think about basically moving the value from the model itself, rather than building something which makes use of the model and gives basically the final user the opportunity to deploy at different scales in different environments, and then basically you would capitalize on the actual business value of the software itself, not the model, which is basically just a vehicle in this case.
yeah, that might be true. Again, I'm not a business person. I might not be in the best place to say that. As of right now, it seems like the first mover's advantage is a big thing. We see it in OpenAI. I don't think they build that much better than the other competition. It's just everybody uses the products. And I was telling you about Meta AI that pledged into open source and all. It's making all those models that they're exploring publicly available, we can play with that. They're not doing the same with the data. So again, it comes back to what do you do with those models? You have the necessary data to take advantage of that.
Yeah, so my answer would be that the actual dollar value is in instrumenting and putting those models into production. That's where the dollar is. If you take into account the amount of capital which is being invested just to build the computers now, you have no chance of returning that investment unless you are a platform company. And by platform, I mean you have your own research, you have your own models, but you also integrate other models, open source, including open source, and you have the whole tool chain to put that, to let the users put that into production. So that's what Microsoft does. That's what Google does. And others. The value will be, of course, captured. So the niche value comes from the quality of the models, probably, but you have to amplify that with something, and those are the tools to put it into production.
Okay, one more question, and then we go to a network session while the guys will answer your questions on the podcast.
I was just typing, but I'll go. Yeah, so I have a question specifically for Mihai. I was wondering if your company is, if you are doing benchmarks of the different models yourselves, and if so, what are you benchmarking for?
We're not doing benchmarks in the pure engineering sense. We just play around with some. So we do some kind of benchmark, but it's not very, I would say, it's not very accurate. And it's not very, how should I say, rigorous in terms of comparison. Yes, we do comparisons. If that's, we aim for very different things, depending on the phase of the project, in our case. So we have 3 major phases, 4. One would be a POC, which doesn't really matter to optimize for anything. The second one is a pilot, which is we build something functional that resolves the problem, but in an imperfect way, or very far away from perfect, but it solves the problem and it is usable. And here we aim for smallest cost possible for decent efficiency, and not look at guardrails like security and so on and so forth. That would be the pilot. When we go into production, we might change that. And then we have to go into much more into security, into explainability, things like that, responsible AI and all the other stuff. And in between these 2 phases, you might actually have to change the whole engineering, including the model behind. Because I'll give you a very, very simplified example. In the pilot, you might use GPT 4.0 because it's much more, it's perfect for some scenarios, right? It costs 20 times more than GPT 3.5 on some use cases, okay? So you cannot go with that into production. Just a very simplified example. We don't have dozens of projects yet. We have only 5 or 6 done already, but that's what we discovered so far.
Okay, so we'll leave it here. You take the QR code, ask questions, and the guys will answer in the podcast with Raul. And for the rest of you, if you come all around the corner, there is some sweet stuff and bubbly Petrovasello wine for you. And yeah, let's continue there and see where we get with our native intelligence after, yeah, that sweet wine. Thank you.